Today we're going to do practice problems from Algebra 1, Module 1, Lesson 16, Solving and Graphing Inequalities Joined by AND or OR. Question 1. Solve each compound inequality for x and graph the solution on a number line. A. 9 plus 2x is less than 17, or 7 minus 4x is less than 9. This is an inequality joined by the word OR with two parts. So we have to solve each two parts separately. We'll take 9 plus 2x is less than 17 first. I would want to go ahead and subtract my 9 off of both sides first. It'll look something like this. So then what we'll have is we'll have 9 minus 9, which will cancel on the left, and 17 minus 9, which will make 8 on the right. So 2x is less than 8. If I divide both sides by 2, x will be less than 4. Alright, moving on to 7 minus 4x is less than negative 9. I'd want to go ahead and start off by subtracting 7 from both sides. It'll look something like this. 7 minus 7 will cancel. Negative 9 minus 7 will make negative 16. When I bring the 4 down, I have to bring it down as a negative number because it is a minus 4. So I need to divide both sides by negative 4. Don't forget that when I divide an inequality by a negative, it does flip the symbol. The video in Lesson 14, Solving Inequalities, goes into a little bit more detail as to exactly why that is. So what we get is x is greater than positive 4. Negative 16 divided by negative 4 gives me positive 4, and because I divided by a negative, it flips the symbol. So we're going to need to graph x is less than 4, or x is greater than 4. So I need all those numbers that are less than 4. So 3, 2, 1, so forth and so on. Or I need all the numbers that are greater than 4. 5, 6, 7, 8, okay, etc. So really the only number that I don't need is 4. So a more concise way to write this inequality is with a not equal to sign. So I need to graph x is not equal to 4. So I'm going to show on my number line that I can't include the number 4 by using an open dot. I then want all the numbers that are less than 4. So I'll have an arrow shaded going to the left. I also want all the numbers greater than 4. So I'll have an arrow going to the right. B. 6 is less than or equal to x divided by 2 is less than or equal to 11. This is an AND inequality. We could separate it into two parts and join it by the word AND. However, that's not necessary that we separate it in order to solve it. The question is, what's going on with the x? The x is being divided by 2, and in order to undo that, we're going to have to multiply everything in the inequality by 2. This is slightly different from an equation in that you've got the front and the back, and both have to be multiplied by 2, as well as the middle. It's going to look something like this. 2 times 6 is less than or equal to 2 times x over 2 is less than or equal to 2 times 11. When I simplify this, I get 12 is less than or equal to x is less than or equal to 22. Now because this is an AND inequality, I need to make sure that I satisfy both the left and the right side. X is in the middle, which means that it has to be greater than the 12. And it also has to be less than the 22. Alright, so down here on my number line, I didn't have any numbers down there yet, so I'm going to go ahead and put some. We'll go ahead and start it at negative 10. Okay, it counts by tens, so we'll do 0, 10, 20, and 30. Alright, we need to go ahead and start my inequality at 12. So I'll get me a closed dot to represent the less than or equal to symbol and place it on the 12. I'll get another closed dot and place it on the 22. I want to graph the numbers that are greater than 12. All right, so that is going to be going this way. I also want to graph the numbers that are less than 22, so that's going to be going this way. What I have is I have 3 sections to my graph. I have what's before the 12, I have what's in between the 12 and the 22, and I have what's on the end here after the 22. Because this is an and inequality, I'm looking for the spot on the graph where both inequalities are true. For example, before the 12, only one inequality is true. And after the 22, only one inequality is true here too. So it's in the middle is where I'm going to need to shade. Okay, so I'll take those arrows away, and I'll go ahead and bring us just a shaded line to go in between the 12 and the 22. Question 2. Give an example of a compound inequality separated by or that has a solution of all real numbers. Most or inequalities are shaded to the outside of the number line. Okay, we're looking for a special case here. We want an or inequality that's going to have a solution of all real numbers. So I need to pick 2 numbers to write 2 inequalities. I'll just go ahead and pick -2 and 3. Okay? I want this whole number line to end up shaded. So I want the part before the -2, I want the part that's in the middle, and I want the part that's after the 3. If I were to just shade the outsides, I would completely miss the numbers that are in the middle. So I need to somehow figure out how I can place my inequalities to get all numbers on this number line. All right, well, let's start with the -2. What if I go greater than -2? That would take up 2 sections of the graph. And what if I went less than 3? Once again, another 2 sections of the graph. So all 3 graphs would be represented by at least one part of the compound inequality. Okay, so I'm ready to type that in. My first part is going to be greater than or equal to -2. Because it's a solid dot, I'll use a greater than or equal to. So x is greater than or equal to -2, or x is less than or equal to 3. Part B, take the example from A and change the or to an and. Explain why the solution set is no longer all real numbers. Use a graph on a number line as a part of your explanation. Okay, so we want to take the exact same inequality. So we want to take 2 and we want to go greater than the -2. We're going to take 3 and we want to go less than the -3. All right, so now I'm changing this to an and. What does the word and mean? And means that both inequalities have to be satisfied. So before the -2, there's only one piece that's satisfied. In the middle, I have 2 pieces satisfied. And on the end, I have only one piece satisfied. So it's not going to be all real numbers anymore. It's only going to be the numbers that are in the center. Okay? So the solution is now, the numbers in between -2 and 3. An inequality separated by the word and has to satisfy both inequalities. And those have been practice problems from Algebra 1, Module 1, Lesson 16. Solving and graphing inequalities joined by the word and or.